Welcome back to Understanding Python. My name is Jake, and today we'll be exploring Python descriptors. In this video, we'll dive into what descriptors are, how they work, and how they allow for unique attribute behavior in your code. Descriptors are a powerful tool that can greatly enhance the functionality of your classes, and we'll be discussing a number of ways in which they can be used. So if you're ready to learn more about this essential Python feature, let's get started. You may not realize it, but Python actually uses descriptors all over the place. For example, in my initial video on basic classes, we actually covered 4 uses of descriptors, because not only are properties, class methods, and static methods descriptors, but so are bound methods themselves. Their implementation is just some of the background magic that Python does, but exposing a simple interface for us so we don't have to worry about the details when we're writing our classes. Now, descriptors themselves are a relatively simple concept. Like many other subjects I've covered, they basically just allow you to customize attribute access and behavior. And there are 2 main types of descriptors. There are data descriptors as well as non-data descriptors. It may seem a bit weird at first, but we're going to start actually with non-data descriptors first, and we'll explain things as we go along. First, let's just start by defining a simple class called yes. This is going to be a non-data descriptor that just returns yes. And the way that we do this is by implementing one of the descriptor methods that we have available to us, and that's going to be dunder get. Now this takes a couple of arguments. Let's not worry about them just yet because we actually won't be using them for this particular example. And we're simply just going to return yes. And that's it. We just wrote our very first descriptor. There's not much to it. We're still unclear of exactly what's going on here with instance and owner and what's really happening with get. But we'll explore more of that in our testing. First, we need to actually show how to use this descriptor. So we'll create a simple test class, and we'll create a class level variable called alpha, because it'll be our first. And this will just be an instance of our yes descriptor. And from here, we can start seeing what that looks like. So let's load the file. Right now we have our 2 classes in here. Next, we'll just simply create an instance of test class. Doesn't take any arguments, and now we have test.alpha, which is always going to give us yes. So that's all this descriptor does, is anytime that something tries to access the attribute here, or access alpha attribute, it simply just returns the value yes. Now realistically, we could change this to anything we want, even changing it to no, but we don't want to do that. Now there's a lot more we could get into with non-data descriptors. However, since they're the most basic form of a descriptor, I think it'd be more useful to build on top of that functionality when we get into data descriptors themselves. And we'll also explain what each of these arguments are that go into our descriptor methods. So let's do that now. One of my favorite ways to explore call patterns and see exactly what's happening when Python interacts with magic methods like these is to just create noisy classes to figure out exactly what's being passed around. So let's do that now with a noisy descriptor. And this is simply going to be a data descriptor that prints out all of its actions. And just like when we started with our non-data descriptor, we're going to start our noisy descriptor with a get method. This time though, instead of saying instance and owner, I think I'm going to clarify what I'm really expecting to be passed in by saying object and object class. Starting to get a little bit of hints of what's happening here. So let's write a formatted print statement that'll give us a bit more clarity when we're trying to use this noisy descriptor. Our print statement is just saying getting the value from object of type and then the object's class itself. There's 2 modes that we're going to want to check here. If an object is being passed in, or if an instance is being passed in, we're going to want to return ourselves getting a particular attribute from that object. And we'll just say that the actual value is underscore noisy, right? Because we need some type of reference on the actual parent. And we'll default to none if it can't be found. Otherwise, we're going to try to get it from the object's class. Same thing, getting noisy. Otherwise, we default to none. And don't worry too much about trying to understand what's happening right here. As we run this and start to look at what's being passed around, a lot of this is going to make a lot more sense. Descriptors are one of those cases where you really need to see things running to get an idea of what's flowing where. Now, to make this a data descriptor instead of a non-data descriptor, we need to define at least one of two other methods. That first method is going to be under set. Of course, take the object that we're setting the value on, and then the value itself. And we'll simply just say setting value equals on object. And just as simply, we're going to set it on object. We're going to use underscore noisy again and pass in the value. So when our descriptor is being told to set a value, we're actually writing it to an underscore noisy variable on the object itself. And then delete is going to be much of the same. Again, it's just delete, and we're just being asked to delete that from the object itself. So we'll say that we're deleting noisy from the object. And we'll do that with delatter or delete attribute object, and what we're going to delete from that is underscore noisy. All right, now we have our noisy descriptor defined. Give ourselves a little bit of room, and then see how we add that on to our test class. So just like before, we'll create a new class level variable. This one will be called beta, and it's also going to be a noisy descriptor. Now, since we're not setting anything there by default, let's go ahead and create a .init for our test class as well. So it's going to take in self, and it's also going to take in, to be a bit more clear, we'll just say value here. And say self.beta is equal to value. So without further ado, let's load the file and see what's going on. Okay, so far, nice and clean. We've now tried to get, set, or delete any of the values here, so we're good. Right away, since we haven't set the value beta here, and the way that we're doing the lookup is we're just getting the attribute noisy from our test class. If we were to try to get test class.beta, we'd say that we're getting value from object is equal to none. This is important. Object is equal to none. Remember, object is actually the instance of a class itself. Of type, and we have object class is equal to our test class. So yes, the object class is actually being passed in there. And since it's defaulted to none, we get nothing printed out. Maybe for a bit of clarity, we'll change this to nothing here. So yeah, with that clarity, let's reload this and see what that looks like. There we go. Test class.beta, same thing. Object is equal to none, so it's not an instance, which means that we're calling it from a class itself, and it returns nothing here because nothing has actually been set. Now, if we create an instance of test class, we'll just pass in a value of 15. We see setting value is equal to 15 on object, and here we have our test class object here. That's the actual instance of test class itself. So we look at the set, we're passed in the instance, and then the value. Now, if we were to check test.beta, we have getting value from object is equal to that instance. See, same instance as above. It can now get that value that we set on the test instance. But where's that 15 coming from? Well, let's look at test.dunderdict. If we look in here, we have what we consider in the Python world a private attribute. You can't see me, but I'm doing private in air quotes because we have the underscore that prevents it there. So if we look here, we should see noisy. Exactly. So when we were calling set, we were actually saying test._noisy is equal to 15. That's what's really happening here in set. And when we do the get, it's really just returning test._noisy. Or if that was set on the class, it would be test class._noisy. And then if we were to delete test.beta, it says it is deleting noisy from our test class object. So if we look at our dictionary again, we now see that _noisy is no longer in our instances dictionary. And if we were to try to call test.beta, it says nothing here. So it's defaulting back to that behavior that we see when it can't find the value. So you're starting to see a little bit more clarity into what's going on with descriptors and a little bit of the value that they give you. Well, there is still more to this. And one really important thing, because if you stop here, you're going to run into some significant bugs in your code. And I'll show you exactly what I mean by that. What happens if you want to use two noisy descriptors in this class? Say we want a gamma attribute here to also be a noisy descriptor. Well, let's see what happens. We'll reload this, create another instance of test, and we see, again, setting the value 15 on that instance. So far, so good. Test.beta is equal to 15. Test.gamma, since it's not been set yet, oh, but what's going on here? How come test.gamma is giving us 15? We never set that value there. We never assigned a value to gamma. Let's see if we can correct that. Test.gamma, and let's set this equal to something different. Literally something different. Okay, cool. Test.gamma is now something different. So if we look back at test.beta, oh, wait, that's now something different. What's going on here? Let's look back at our dictionary. We still have noisy, and now it's pointing to something different. If we set test.beta is equal to 5, look at test.dict, now noisy is 5. That's because both of these are using that same private attribute on our instance, _noisy. So in our current implementation, we can't use more than one noisy descriptor. But the authors of Python are smart, and they've thought about this problem, and they have a solution for us. And the form of that solution is through a new magic method called setName. We have dunder set name. And this is going to take in 3 arguments. We have self, we have owner, and we have name. Since this is noisy, we'll also make it noisy. And we'll just say received name from owner. Now, since we are a class, we can store some information. So what we're going to store is a private name. You can call this whatever you want, but for this example, we're just going to keep it nice and simple and do an F string with an underscore and then name. Okay. And then each time that we're going to use noisy in the rest of our class, we'll just replace that with private name. Private name. And we can also replace that here. This time we're going to say we're getting private name from object of type class. So let's test this out and see what it gives us. Okay, right away we see a couple new statements here. Looking back at our test class, we see received name is equal to beta from owner test class. And then received name gamma from owner test class. So when it does this assignment here, what Python is effectively doing is taking our instance of noisy descriptor and calling setName on it, passing in test class as the owner, and then the name beta here as the name. And what this allows us to do is understand which variable we're referring to when we're doing our get, sets, and deletes. Look at our previous example. Test is equal to test class. Pass in 15 is the value. Here we see we're setting value equals 15 on that test class instance. And if we look at our dictionary, we see now underscore beta is equal to 15. We look up the value for gamma. We see nothing there. Good, we have isolation. Set a value for gamma. Sure, we'll do something different in there. And look up the dictionary again. We now have underscore beta and underscore gamma actually storing the values. That's much better. So the big important thing here, if you're going to write a data descriptor that you want to use multiple times within the same class, you need to take that account some way. And one of the best ways to do that is through set name. All right, so that's the basics of how you define a non-data or a data descriptor. Those are effectively the basic methods that are part of the descriptor protocol. But what are some things you can do with these descriptors? Aside from just being able to print out what's going on with the descriptor, what you can actually do with them is entirely up to your imagination here. Some common examples are implementations for plugins, validation, type checking, caching, lazy loading, and a lot more. But one thing I think is a fairly short and illustrative example is defining what could be considered as close to a true constant as you really get in this Python space. So let's create a new data descriptor called simply constant. And I'll show you how I want this to look so we get an idea of what this spec should really look like. And sometimes it's easier to write out what something should look like from a user standpoint before you start implementation so it can guide your implementation itself. You want a new variable delta to be an instance of this constant. But what's going to be the value of that constant? Well, if we would just stop here, we wouldn't be able to change the value of delta. So delta would always just be equal to what in this instance? Well, these are still just classes, right? And we can pass in values during class instantiation. So we can set our constant here. And our default for this will be a name, Kiara. Understand that we want a value to be passed into the init. Let's define our init. Of course, we have to take in self, but we're also going to take in value. And simply just store self.value is equal to value. Now, the get is easy enough as well. Under get self, we can effectively ignore these, but we'll just accept them anyway because we're just going to be returning self.value. And then for set, since it's a constant, we'll also be ignoring these, and we're going to raise an attribute error. And in that attribute error, we're going to say we can't change a constant's value. All right, so we should have our constant. But before we run it, let's fix that typo there that you're probably yelling at the screen about. Changing the ini to init, so it's an actual valid init method. And we'll load this in. We can ignore our noisiness from before, create our instance of test class. Let's keep on passing in 15. And right now, we should have delta, which is a constant. Test.delta is equal to Kiara. Now, that's not stored anywhere in the instance dictionary because, again, remember, it's a descriptor. It doesn't need to store it in the dictionary. And if we try to change delta to something else, like changed, it raises that attribute error, telling us we can't change a constant's value. Now, if you don't want your constant descriptor to be that harsh, you can absolutely have it chill out a bit. Because again, this is our descriptor, and we can implement whatever behavior we want in it. So here we're going to say strict. It'll be a new option that we can pass into classes. By default, our constants will not be strict. But what does this strictness mean? Well, we'll just check this here. If self.strict, we'll raise that attribute error. Otherwise, if we're not in strict mode, we'll just effectively ignore it. We're not going to set anything on there. We're not going to change the value, but we're not going to raise that attribute error. Alternatively, you could log something saying, hey, you tried to change a constant value, but we'll just leave it here. If we're not in strict mode, then we don't need to raise anything. Keeping the naming going, epsilon be a new constant. We'll say I'm strict is the value of the constant. Set strict is equal to true. Now if we reload this, create a new instance of test class, again test.delta is equal to Kiara. If we try to change it, it doesn't do anything. Still gives us Kiara, but it doesn't complain. However, we have epsilon, which tells us that it's strict, and if we try to change it, it will raise that attribute error. Okay, cool. Now that we've made it through that, and you made it to this part of the video, we'll wrap up with the easy way to do custom get, set, and delete methods on your class. And that's by revisiting our property decorator from that basic classes video. So we'll simply start with a property. We'll define our property method. Again, keep that naming structure. Call it Zeta. And this will return getAttr from self. It's going to look up, just for ease sake, underscore Zeta. None. Now, something interesting that property allows you to do that I don't think a lot of people know is it allows you to set custom setter and deleter methods by reusing that property you just defined. We have a new zeta.setter decorator available, and we can override what we just had, self and value. And we'll just say self.under zeta equal to value. And then deleter will be much the same. Zeta.deleter. Again, we're overriding Zeta. This doesn't take any arguments, and we can just delete the attribute from self, which is underscore Zeta. All right, so for one last time, we're going to reload, create an instance. This time we have test.zeta. Right now it doesn't have anything in it. Change it to something. Now if we look at test.zeta, we have something. If we look in the dictionary, we have underscore Zeta set there. And then finally, delete test.zeta. It deletes it from the dictionary. So without having to implement our own custom descriptors, we can use property to give us quite a bit of control that we otherwise would have had to have written a full-on class for. And that wraps up this video. Now that you have a good understanding of how descriptors work, try implementing them in your own projects and explore different use cases. As always, today's code will be added to the Understanding GitHub repo, so check the description for a link. And of course, if you have any questions or suggestions for topics you'd like me to cover, let me know in the comments section. To keep up with the series, please consider subscribing. Thanks for watching.